Hello everyone, this is Abhijit Singh, a second year undergraduate, and in this video I will be telling you the solutions of Codeforces 806 Division 4 round. So let's begin with the first problem. In the first problem, the question given is there is a string of length 3 consisting of uppercase and lowercase letters. Check if it is equal to yes, where each letter can mean any case. So the problem given to us is that we have a 3-letter word and we have to just confirm it whether it is yes or no, and the up means it doesn't matter whether the characters present are in uppercase or lowercase. So what we can do is we can simply convert it into one of the following, means either we can convert it into lowercase or uppercase and check with the following yes. So what I have done is basically is I have converted it into lowercase, and which I've used this STL function and compared it with the yes, which has all lowercase characters, and if it is so I'm printing yes, or and if it is not so then I'm printing no. So this was the solution for problem A. Now let's move to problem B. So in this problem we have been given that there's a string and we have 26 problems, and what happens is that if a team solve the problems first, that team gets a balloon and the first team gets an additional balloon. So in the string what we can see is if a character appears for the first time, we can add 2 to the answer, and if it occurs for the second time we can add 1 to the answer. So this is the basic logic behind the problem. So let's move on to the problem, code for the problem. So this is my code. So first I have taken the string as input, and then I have used a map to store whether a character has occurred before or not, and if it has occurred, so I am adding 2 to the answered, if it hasn't occurred, so I am adding 2 to the answer and then incrementing the count for that character to 1, and if it has already occurred, then I am just incrementing 1 to the answer. So I am getting my answer by this way. So let's move to the third problem. So in the third problem we have been given a lock consisting of n digits, and the values after making some changes are given to us as AIs. And what happens is the changes and we are given n changes, also the changes which has made to each of the digits of the lock. So the changes to the first digit, so a string is present of k characters, which says us what are the changes made to the digit of the lock. Up means it has been, the ith digit is increased by 1, and D means it has been moved by below, and we are given the final string. So like in the first case, the digit present is 931. One second. 931, and the changes made to the first character is like 3DDD, and we are getting this thing. So actually what is happening is let's say some x was present, and then what we do, we make a down operation. So what happens, it becomes something like x minus 1 plus 9 modulo 10, and then similarly for next to a D it happens x minus 2 plus 9 modulo 10, plus 10 modulo 10. So this is the change that is taking place. So what we can do is means I will explain it in the code. So what we can do it is, so what I'm doing is for each for changes in the each digit, if it is D I am incrementing it, and if it is U then I am decrementing it, and then adding CT modulus 10. So what I basically want to do is, so what was happening is, so if a number was x was present, then after 3 D's are present, then it becomes x minus 3 plus 10 plus modulo 10. So instead, what is happening? It is getting decrease. So to reverse the change, we will have to increase for each d. So I am so in this condition, I am increasing for each d and decreasing for u. Since means we have to reverse the change, and so as you can see, I am modifying ai to ai plus ct modulo 10, and there is an additional condition which I am putting here, which is ai plus equal to 10. I am putting this because there might be a case that the negative value might make ai to negative, so we are adding it to avoid that situation. And this is the code from my problem. You can have a look at once. So let's move to the next question. So next question, we have been given n strings, and we have to for each string we have to check whether it can be made by concatenating two other strings present in the list of strings. So this is what we have to do. Yes, and what is the, and we can concatenate even two same strings. So what we can do is, like, we have been given n strings. We can we can make a map of string and an integer, string and integer. We can make a map and then store the occurrence of each string. And then like if we have been given a string AB, so we can try to break it in all combinations possible. AB, since the length of string is only 8, so only 7 breakups can be done. AB, maximum number of breakups, AB, AB, and then we can check whether in the map of string versus integer, where occurrence of A and B both are present, or whether an occurrence of AB and AB is present, or a single occurrence of AB is present, or whether an occurrence of ABA or B is present. And if any of the following case becomes true, if any of the one of the conditions becomes true, then answer will be 1 for this string. The answer will be 1 for this case, otherwise it will be 0. Otherwise 0. I will let me show you the code. So this is the code for this problem. So I am incrementing for each string. I am storing its count in the map, and then I am breaking it into if its length is j, then all the j minus 1 partitions, and if checking both the strings which are found by breaking it up is present, then for this the answer will be 1, and I'm breaking it, and I'm means either storing 1 if f becomes 1, or else I'm storing 0. So this is the code for this problem. So let's move on to the next problem. So in the next problem, what we have been given is a matrix of n cross n, and we have to tell if after rotating it by 0 degree, 90 degree, 180 degree and 270 degree, whether the matrix remains same or not. So what is happening is I can draw a figure and show it to you. So initially the matrix, I am representing the elements of the matrix by numbers, and I am taking a 4 cross 4 matrix. So initially the matrix was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then it becomes, after rotating it 90 degree, it becomes 13, 9, 5, 1, 2, 3, 4, and then this 8, 12, 16, and then 15, 14, 13, and then 5, 6, 10, and then 15, 12 and 15 was 11, and 8 and 3 was 7. So this is the new matrix after rotation by 90 degree. 0 degree, 90 degree, and then after 270 degree I will show you the matrix. It will be 16, 15, 14, 13, and then 9, 5, 1, 2, 3, 4, 8, 12, 16, and 11, 10. One second. 11, 10, and then 7, 6, and then sorry, this was after rotating 180 degree. This will be after rotating 270 degree. 4, 8, 12, 16, 15, 14, 13, 9, 5, 1, 2, 3, and then 7, 11, 6, 10. So this is the matrix after rotating 270 degree. So you can see the first position. At the first position 1, 13, 16, 14 are present. At the first position 1, 13, 16, 14 are present. Sorry, 1 second. 1, 13, 16 and 4 are present. At the first position after 4 rotation, these 4 are present. So what we have to make an observation, what is happening. So what is happening is in the first, the column which was this becomes this in the second rotation, and this in the third rotation, and it becomes this in the fourth rotation. So what we can do is we can check each of the outer columns and see whether it is we can check whether it is like I will try to show it to you. What we will do is we will compare this column with this column, and then 1 second, this column. What we will do is we will compare the element of this column with this element, and then this element with this element, similarly this element with this element and this element. So what we will do is we will compare these 4 elements and see what is the count of ones and zeros. If all 4 are ones, then we will not add anything to the answer. If 2 of these are ones, then we will add 2 to the answer, and if one of this is 1, then we will add 1 to the answer, and if 3 of these are ones, then we will also add 1 to the answer. How we are doing this? So if all 4 ones are there in this position, all 4 ones, so what will happen? All are identical. So after rotation at all the 4 positions, these will interchange places after each of the rotation. So since they are all the same, so the transform matrix will also be same. So where we don't have any problem, so we don't have to make any changes to this. All 4 zeros, then also this will happen. So what happens if all 3 if 3 ones are there? So 1 will be 0, which when change place will change the matrix. So we have to make that, we will transform that 0 to 1. Okay, then if 2 ones and 2 zeros are there, if 2 ones and 2 zeros are there, so we will transform either the ones or the zeros to, I will supposedly transform, say let's ones to zeros. And if what happens is if 1 ones is present, so we will transform that 1 to 0. If 1 ones is only present, then we will transform that 1 to 0. And yeah, so this is all the possible combination. So we will have four means if one is 4 or 0, 0 transformation. If one is 2, 2 transformation. And if one is 1 or 3, then we will have one transformation. So this is a transformation needed based upon means for considering all the four positions, four different positions. These four positions we need to compare is like this and this. Means after rotation, we have to, after rotation, each position will acquire a new position after each rotation. So we will have to consider means the position of a cell at all means the a cell will acquire four different positions. So we have to consider all those four different positions. So let me try to show you a code and make it bit clear. And what I'm doing is I am telling one more thing how I'm proceeding. So what I'm doing is firstly I'm comparing the outer layer of numbers, zeros and ones. This one I'm comparing. Then what I'm doing is I'm comparing the inner layer, this and this and this, and so on. If the size will be bigger, we'll try to move inwards following the same pattern. So what I'm doing is I'm positioning 2k's means I'm storing the two endpoints which will be there for my means boxes. So like if it is a supposedly a 3 cross 3 one, so my first positions will be this and this, then it will come down to this means this one only, this only in the second combination. So let me show you a code and try to make it more clear. So what I have done is firstly I have kept this as 0 and n-1 fixed at both the endpoints, and then what I have tried to do is I have tried to count means push back all the elements in a double two-dimensional vector. For in the VS0 I am storing the zeros and ones of the this part. In VS0 I am storing for this part. In VS1 I am storing for this part, and in VS3 and 4 let me VS2 and 3 let me check. In I am storing this in VS0, this in VS1, and this in VS2, and this in VS3. So this is how I am storing things, and then I am counting means storing the whole line. Then for each of the line I am comparing the starting most element of this. I am adding the sum of all the four positions where a single element will be present, and following the thing which I was saying to you. For 4 ones like the for means if it is 4 or 0 ones I am not doing anything. If it is 2 I am adding 2 to the answer, and if it is 3 or 1 I am adding 1 to the answer. And how I am adding all the four positions, like I am taking the first position of this one, and first of this one, first of this one, and first of this one, and adding all these four, then second of this one, second of this one, second of this one, second of this one, and adding all these, because this will move on to there, this will move there, this will move here. So this is what I am trying to do. And there is a special case also what I am doing. So if the point is an end point, I am storing it differently and dividing whatever I am getting by 2, because what will happen is this endpoint will be present in this and this. So I will count rotate means changing it twice, once for this and once for this. So what I am doing is here, if it is if it is an endpoint, means if it is 0 or at present at the end, I am storing it differently in a temp value, and I'm adding it to the answer by dividing it by 2, and then I'm squeezing the length of the straight line which I'm considering. Means if it was like for 4, if it was of length 4, I am squeezing in and making it of 2. Like this was 0 and 3, then in the next step it is 1 and 2, and by this it is proceeding, and so I get the final answer here. And so let's move on to the next question. So this was a fairly simple question, the logic for which I'm telling you. So I'll read the question once. I have to find all such pairs where I greater than AI and AJ greater than J and J greater than AJ. So we have been given an array, and we have to find all pairs for where J greater than AJ greater than I greater than AI. So what we can do is, let me store the array 8 1 1 2 3 and 8 2 1 4. 1 1 2 3 8 2 1 4. So I am storing the I for your 1 2 3 4 5 6 7 8. So the positions where in all the elements we have a condition like k greater than a of k, if k is any index. So what I will do, I will store all such things in a pair of vectors. So this will be one such thing where k is greater than a of k. This will one such combination. This will be one such combination. This will be one such combination, and this will be one such combination. So we have 5 such combinations, and what I'm doing is, in one of the things I will store it based upon AI greater than I, AJ greater than J. So I will, in one of the pair of vectors, I will store based upon the value of AJ and sort it. And after sorting it, what I will try to do is, I will store it in 2 different vectors. I will, so see, I am storing, taking 2 pair of vectors. In the first pair of vectors, I am keeping the I plus 1 in the first position of a pair of vectors, and in the second, I am storing AI as the first position of pair. And what I am doing is, means I am then sorting all the elements of S. So what I am doing is, I am basically sorting it based upon the value of AI. And then I am storing it in T1, a different vector, just for using lower bound on T1. And then what I am doing, I am iterating on all the elements of the vector F, in which I have stored the value as AI comma I pairs for all such pairs where I greater than AI. And then what I am doing is, I am taking first pair of the vector, means first element of the pair, and then I am doing a lower bound on T1, and T1 stores all the values of such pairs where means I greater than AI, and it is sorted based upon the value of AI. So what I am trying to do, I am using this value plus 1. I am using lower bound using the first value of first and plus 1. And so what I am getting is, like, I will try to show it to you. What does T1 contains? T1 basically contains values of AI in a sorted way. So 3 3 2 2 1 3 2 2 1 1. I am applying a lower bound on this array for each of the elements of the array F, in which I have stored all the AI where I is greater than AI, and I am doing a lower bound on this array by using I plus 1. to see if there is an index to see if there is an index uh, to see if there is an index which is means greater than I plus 1, to see if there is a value of ai in the array which is greater than this one. Sorry, this will be in sorted order. I have written it reverse sorted. So 1 1 2 2 3 3. So the what are the values of ai I plus 1? So it is I plus 1 is 2 3 4 5 2 3 4 6 7 2 3 4 6 7. So first I will use lower bound on this array using 3, and then I will get two indices, these two. One second. Let me see the test case ones. 1 1 2 2 3 8 1 4 1 1 2 2. Yes, so what are the positions for which I will get for 1 1 2 2 3 3? 1 2 3 2 1. Sorry, this is different. 1 2 1 2 2 3. Sorry, here I have written one extra 3. Sorry for my mistakes. And for this, excuse me, so this is what I'm trying to do. And then what I'm doing is, whatever be the size of the this t1, which is suppose some k2, then I'm subtracting this position which I'm getting as the lower bound. Because see, if this comes out to be the position which is greater than the I plus 1, means after calculating the lower bound on first value plus 1, so the total elements which we can take will be this position. So I'm adding this to the answer. So let me show you the code once. So what I'm doing is first inserting these, means two pair of vectors, and inserting this, and then finding a lower bound. And if it is not the end, means if some element is found which is greater than the first element of pair plus 1 value, then I'm means adding to the answer the total size of t1 minus the position at which I have got the lower bound, and then outputting the answer. Then coming to the last question. So last question we have been, so let's lead the route. Last question. So there are n chests. The ith chest contains AI coins, and we need to open all the n chests in order from chest 1 to chest n. And there are two types of keys to open a chest: a good key which costs k coins, and a bad key which does not cost any coins, but will halve the coins in each unopened chest. Including the chest it is about to open, so it will make all the coins from I up till n half. So any key breaks after usage, means every key is one time use key, and we can go into negative value also, means the total amount which we have can become negative. We can go in depth. So we have been given a n and a k, and we need to find means what is the maximum value that we can obtain after opening all the chests. So in this question involves greedy approach. So what we have to do is like 4 5 10 3 1. 1 second. 4 5 10 10 3 1. we have to adopt a greedy strategy, that all the good keys that we will use in the leftmost part. Like if we have to use one good key, it will be at this position and not at any other position in the array. And if we have to use two key, it will be here. If it will be three, then it will be here. If it will be four, it will be here. So whatever be the number of elements in the array, let it be means a1, a2, a3, a4, a5, and what means, and if suppose there is x number of good keys that we use, then this x will be these means we'll use x good keys to open the xmost left chest, because what is happening is all the rightmost elements from where we are using a bad key is getting halved. So all these elements will get halved. So we have to adopt a greedy strategy of opening chests from the leftmost good keys at all leftmost positions. So what we can do is now, so we know that all the good keys will be used in leftmost positions. So what we can use is, like, we can see if we use 0 good keys, what will be the answer. If we use 1 good key, what will be the answer. And then 2 good keys, what will be the answer. 3 good keys, what will be the answer. 4 good keys, what will be the answer. 0 and 5 good keys, what will be the answer. So we can take the max of all the answers, and that will be the required answer. So let me show you the code for this problem. So I'm maintaining a prefix sum to calculate the value from first position up to ith position, so that I can get the sum in O of 1 for all the good keys. So what I'm doing is I'm iterating the loop from 0 to n, and this loop is like iterating from I0 denotes that I'm considering 0 good keys, and IN denotes that I'm considering all n good keys. So what I'm doing here is I'm making j equal to I. So for the positions after which good keys will not be used, their value will start becoming divided by 2. So initially k1 is 2, and I'm dividing it the value by 2, and I'm incrementing k into 2, because for the next element, what happens is we use 2 good keys for a1, a2, and then for the remaining 3 elements we don't use good keys. So what will happen is we will have to take a3 by 2, means we'll take a3 using a bad key. So all the values will become a3, means a3 by 2, a4 by 2, a5 by 2, and then when we'll go for a4, then for a4 also we'll use a bad key. It will become a4 by 5, a5 by 4, and then for a5 it will become a5 by 8. So we'll use these values in our sum. So this is only I'm trying to compute. I have kept k initially as 2, and then divide aj by k, and then adding it to my current answer, and then incrementing j, and then also multiplying k by 2. And if k1 is becoming greater than 10 to the power 9, then I am breaking the loop, because since ai is maximum, ai can be up to 10 to the power 9. So what happens is, see, ai can be max up to 10 to the power 9. And so if k becomes greater than 10 to the power 9, then what happens is all the values of ai that will occur after k becomes greater than 10 to the power 9 will become, the value which we will have to add will be ai by k1, and that will become 0. So we are breaking the loop afterwards. And we are doing this because if we will not break the loop in between, it will give us O of n square time complexity, which we don't want. And then we are considering I good coins, then we are contributing the answer, to the current answer contribution due to the chest open by good keys. So it will be the prefix sum up to that point, and k into I, which will be the number cost for using k good keys. And so I'm taking the max of the current answer versus the answer max value of answer, and at last I'm printing the answer value. So this was the last question, and so here ends up my video. please do like, share and subscribe the video. And it was my first video, means explaining all the problems, so forgive me for my mistakes. Hope you like it. So let's end here.